Inferential statistics help us decide, for example, whether the differences between groups that we see in our data are strong enough to provide support for our hypothesis that group differences exist in general, in the entire population. You will be provided with your 6th module, PowerPoint presentation, video lecture, assignments 11 and 12, 6th short quiz and 3rd laboratory exercise. Your 2nd long quiz will happen on week 8, which covers the lessons from week 5 to week 7. As mentioned before, a student will only have one attempt but will be given time to review. Down to week 9, we will discuss about the chi-square, especially test of goodness of fit and independence. You will know that the chi-square statistic is commonly used for testing relationships between categorical variables. The null hypothesis of the chi-square test is that no relationship exists on the categorical variables in the population, they are independent. An example research question using a chi-square analysis would be, is there a significant relationship between voter intent and political party membership? The chi-square test is intended to test how likely it is that an observed distribution is due to chance. It is also called a goodness of fit statistic, because it measures how well the observed distribution of data fits with the distribution that is expected if the variables are independent. You will have your 7th module, PowerPoint presentation, video lecture, assignments 13 and 14, 7th short quiz. Week 10 will be about the correlation analysis focusing on Pearson product moment correlation and Spearman rank, which is used to quantify the association between two continuous variables, example, between an independent and a dependent variable or between two independent variables. Correlation analysis is a method of statistical evaluation used to study the strength of a relationship between two, numerically measured, continuous variables. It is useful when a researcher wants to establish if there are possible connections between variables. It is often misunderstood that correlation analysis determines cause and effect. However, this is not the case because other variables that are not present in the research may have impacted on the results. If correlation is found between two variables, it means that when there is a systematic change in one variable, there is also a systematic change in the other. The variables alter together over a certain period of time. If there is correlation found, depending upon the numerical values measured, this can be either positive or negative.